the goal of routing is to form these forwarding tables, if you recall, right? Destination IP and outgoing interface. Now, the way these entries are formed is this. If this is a destination, if somebody else on the internet wants to send data to this guy will need to announce its IP address, okay, in an advertisement and travel through the network like this to outside. Okay. That is how the router here discovered, oh, okay, I see a destination potentially this way. So that IP here, and yeah, the outgoing interface is this guy here. Now for a guy, okay, who's connected to the internet this way, that advertisement will go down, yeah, this other interface. So this other guy here, IP prime, yeah, the output interface will be linked here. Yes, that is the general idea of routing. But then you see, for each machine here having an IP address, in order to allow other people sending packets to it, they would each need to send an advertisement announcing its IP address. Okay? And there are these many different IP addresses possible, so potentially worst case, right? Lots of advertisements each of these organizations need to send and travel on these links. And you know what? The most scary thing is this. All these need to go out to the internet, so the ISP needs to send these many advertisements. And that is just not going to scale. Okay, there will be a lot of bandwidth consumption just to send the advertisements. The solution is actually related to the forwarding mechanism in the router. If you recall, instead of listing individual destination IP here, rather we do this, individual prefix, okay, and then outgoing interface. So when a packet arrives, the destination IP address matching the prefix, then we send it out on the outgoing interface. You know what? Isn't this a prefix? Isn't this a prefix? So what we're doing, in fact, in the internet is not to send individual IP address in the advertisement. We send an individual prefix in the advertisement. So what's happening there is a prefix in the advertisement gets here. Router here, receiving it, pass it down further. Router here, receiving it, pass it down further, but also add the entry prefix here. And because it's coming this way, so this OIF is going to point to this interface. So when a packet arrives here, matching the prefix, go on this interface, and coming here, this router is going to forward it similarly down this way, and then coming into the organization 0. So by announcing or advertising the prefix, okay, we also draw the data into the organization, and the data is actually destined for one of the hosts in the subnet anyway. So the routers inside the subnet there, we just we'll be doing further routing there to get to the final destination. Nice. So you see, instead, organization 0, 1, 2, all the way to 7 will be sending one advertisements only instead of these many advertisements. What's even nicer is this, the ISP. Yeah, ISP doesn't need to send 8 individual advertisements out, just send one. Because it's very easy to aggregate all these, right? Because this is the coarser granularity covering, right? Superset of all these subnets prefix. So there's just one advertisement out this way. One on the link, one on this link, and one on this link. Advertisements, the distribution of it, very, very efficient. And so here, the entry is simply 200 something something 6.0, and it goes on this interface. Data matching this will all fit and then go on here. This router here then will split the packet 8 ways, and by checking the destination address of the packet to these 8 different prefixes and see which prefix match better. So that is the idea, and why we say more bandwidth here. This is the third benefit of doing the prefix matching, in addition to what? Making the forwarding table smaller and the lookup process faster.